This problem requests us to calculate a GM at an angle of Loll, and it's a box-shaped vessel. So we're given the length, breadth, depth and the draft, and we're in salt water, and we're given our initial kg, and 580 tonnes of cargo at 7.8 is loaded on deck. Calculate the GM at the angle of Loll. Okay, a couple of things. The depth is nothing to do with this problem of 9 metres, and we cannot use the hydrostatics because it's a box-shaped vessel. The formula for angle of Loll, tan theta is minus 2 times GM over BM, so that really tells us what we need to find. So let's look at how we solve the problem. We have to do a weight kg moments table, but we haven't got the initial displacement. But we are told the length, the breadth, the draft, and they're in salt water, so we can very easily work out our initial displacement. We're given our initial kg, we've put the weight on board, so we've now got our final kg, 4.245. Now, to find the BM, we need the KB and the BM. To find the KM, we need the KB and the BM, because with the KM we can find the kg. So if we get the KB and the BM, that will give us the KM. Take it from the kg, and that will give us our GM. The KB is the draft divided by 2. It's a box-shaped vessel. What you've got to be careful of here, of course, our draft has changed. So there's the formula. Displacement is L times B times draft times density. We know our final weight, we know our length, we know our breadth, we know the density, therefore we can find the draft by moving the formula around. So we find our final draft is 4.728 from the initial draft of 4.1. Divide that by 2 and that's the KB. Of course it's a box-shaped vessel, so the BM is simply B squared over 12D. And again we have to use the new draft. We get the BM, add the 2 together, that's the KM, kg, and the GM of course is minus. So if you did this problem and you got a positive GM, you must have done something wrong, because we have to have a minus GM to work out an angle of Loll. So the GM is minus 0.118. Okay, that's the GM of the vessel before she goes over to the angle of Loll. Now what we have to do is work out the angle of Loll to get the GM at the angle of Loll. So tan theta is a square root of minus 2 times GM over BM. We've got those values already. The two minuses cancel each other out, and that becomes a positive, and we get an angle of Loll of 20.1. Then all we do is now is put those in the GM formula, minus 2 times initial GM over cos theta of course being the angle of Loll, and therefore we get our GM at the angle of Loll of 0.25. So be careful with this. When it says the GM at the angle of Loll, it isn't this GM here. Remember, at an angle of Loll our GM becomes positive, so don't stop the problem at this point. You must then work out the angle of Loll and then get the GM at the angle of Loll.